Come on, guys. There's a precursor. What is it? How are you going to do any of this if you don't know this thing? Guys, get this tattooed on your forehead. Do you know what the worst thing is, though? How would you see it in an exam? Insane, isn't it? Don't take that advice. At least you'll help other people, though. Can you please learn this? Make a mnemonic. Make it today. Make a mnemonic. Alex, that's a good one. What's the rest though? We need the rest. You learnt it by memorizing the first letter of each one. It's crazy. I think it might be easy just to memorize the names. I'm gonna leave this up. Note it down. Take a picture. One second, I need to do something real quick. Where is it? Where is it? Where are you? Where are you hiding? Oh, that's not. Not this. Not this. Not this. Not this. Not this. Not this. So all the first ones till carbon end in -ium. Yeah, fair enough. ChatGPT is really not giving good examples. This is so sad. The limitations of AI. You just remember it in parts, fair enough. Sorry, what was that? You do realize if you just understand which way it goes up. Alright. I'm gonna leave it up to you guys, yeah? Just make a mnemonic, help yourself remember it. This information, very important. And the other information, just remember, is aluminium, yeah? So aluminium oxide is molten. It uses graphite electrodes and anodes. And what was the last bit? Sorry. Is cryolite. That's it. Okay. I don't think there's anything else for that. Anyways, let's get into some calculations now. Quick reminder of some of those mole calculations that we did that day. Let's see if you guys remember it. Did I see your message? 1 second. What did you say? Do I have Monday? it'll have to be Monday, yeah? So I'll let you know about that. Okay, so here's a question. Can I get the empirical formula, please? I think I've given you everything you need for this question. Who's doing it? Let me know who's doing it. Thank you, guys. Keep going. Keep trying. That's the other calculation. That's the other one. That's the relative atomic mass. Josh, that's the one. Okay, no worries, man. No worries. Okay. Basically, what you do, guys, hope you're watching, is you got Fe and you got O. We're going to do a comparison. We're going to do 72.4 and we're going to do 27.6 and we're going to divide it by the mass numbers. Okay, so 56 and 6. Can you guys divide that and tell me what you get? Did you actually work that out, Adion, or did you just remember it? Because it is Fe2O3. As in, like, that's generally what iron and oxygen make. But it's working it out, which is what we want to show. Did you just memorize it or did you just know it? I mean, did you work out? Was it 1.293? You just know it. Okay. Remember, Fe has variable oxidation states. So you can get like iron is 2 and it's 3. So you gotta be careful. Right, what we getting? Josh, is that what these are, yeah? 1.29 and 4.6. Okay. Now, who remembers in maths the ratio 1 to n? Who remembers the ratio 1 to n? Thank you, Ajwa. Thank you, Mohammed S. Awesome. Thank you for that, Alex. So you divide by 1.29 and divide by 1.29. Can everyone tell me the numbers? Because I don't have a calculator near me. Wait, I don't remember what. Oh, my bad, my bad. Sorry, 16. That's supposed to be 16, people. Sorry. I even wrote it here somewhere. I wrote 6 because I put a circle in. Guys, 16. Fix the calculation. No, not 17. I know the games you play, bro. Was it 1.725? No. 1.725, okay. What is it? 1 to what? What's the other one? What's 1.275 divided by 1.725 divided by 1.29? What is it? 1.33? Is that 1.33? Okay. Okay, we need to turn these into integers, yeah? Are you following? We need to turn these into integers. Okay. So what do we do? can we turn these into integers? If I times it by, if I double it, okay, what will I get? 2 and 2.6. If I double it again, no, that ain't gonna work. Basically, if I turn it into a fraction, isn't that going to be 4 over 3 and 3? No, 3 and 4 over 3. Right, so if I times both by... If I times both by... No, that's wrong. Just times it by 3. Yeah, sorry, yeah. If you times it by 3. Times it by 3, that's it. Times it by 3. Thank you, maths people. Right, what's that? 3 for the 1 and 4 for that. There you go. So FE 304. Should we do one more? For the less awkward numbers. We'll do it with maths, yeah? With maths, is it any different? Does the calculation change? With maths, is it any different? So this one I give you percentages, but the formula for iron oxide is Fe2O3. Yes, but remember, Fe is a transition metal, so it has varying oxidation states. So this could have been a nice, this could have been like, I don't know, like with a different electrons, different number of electrons. Remember, you get Fe2. Basically, I'm trying to make that a whole number. Like, how can I times, what can I do to 1.33 to turn it into a whole number? If I times it by 3, I get 4. I want a whole number. Yeah. Let's go. So Fe304, correct. If you need the numbers, it's 1 second. So C12.6, H11, oxygen 16, 16.8. In the question, they wanted 1, 1. Can I go back? I can. Take a screenshot. Take a picture or something. This is empirical formula. Correct. Find empirical formula. You get the screenshot? I times it by 3 because I'm trying to make a whole number. So 1.333 times by 3 gives me 4. The aim is to get a whole number. It's close, isn't it? We're rounding. It's never going to be perfect. These are just like, you know, they're estimates. Or they're rounded numbers themselves. What's that? 0.05. So if I want to turn this into a whole number, I should times by 10. And I haven't achieved that yet, so I times that by 10 too. Oh, I times it by 2. Guys, we've made it. Houston, we do not have a problem. We have an answer. If I get something like 5, 10, 5, do I simplify that? Yeah, something like that. Empirical formula is the most simplified ratio, basically. That's what you want to remember. I don't know. It's a weird compound, isn't it? I don't even know. Who knows? But that's definitely the answer. Guys, you need to kind of like forget what you're familiar with seeing. Okay, don't think yourself, oh, C3H, like, it won't be that. Okay, let's go for this one. Right, this is how this question is going to show itself, yeah? Are you guys ready? This is how it's going to show itself. I don't want you to go into the exam and say, yo, I didn't see it, I didn't learn it like this. Don't you divide by the smallest decimal? Alright, let's do that. Yep, that's absolutely spot on. Spot on, spot on. Take the smallest decimal. Thank you for that. 1, 2, 1. Yep, that's the one. That's what I do. Wait, maybe I should have done that here. I did do that here. Okay, an oxide of copper was reduced to copper metal by reaction with oxygen. An oxide of copper was reduced to copper metal by reaction with oxygen. Copper oxide plus hydrogen gives you copper plus water. Use the table to find the empirical formula of this oxide of copper. In other words, does empirical formula come up in AQA? Let's ask the chat. What do you guys think? Does it come up? Where are you? Where are you? Where are you? AQA specification. Chemistry combined. Boom. So we're going to go chemistry. We're going to control F, empirical. And there we have it. The suspect is hiding right here. So, students should, guys, do you notice the writer's use of the imperative should? Should be able to work out the empirical formula of an ionic compound. There we go. Okay, can you go back so I can, I hope that answers the question. So I can take a screenshot, please do. AQA being haters recently. Hi there, Zion. Alright, back to the question, yeah? Back to the queue. How have you... I know, man. I know. I'm quick like that. No, apparently I'm not. Right, okay, so... Let's go. Use the data. So we basically have something going on like this, right? CUXOY. And we need to know those numbers. Agreed? So let's very quickly go into the periodic table and let's try and find some information. What number goes in the top box? Can everyone go find it? And oxygen's easy, so we can just go ahead and put those in. What number is it? 63.5. Okay, there we go. So we've done that. We're going to the periodic table. We put 63.5. Okay, don't need that 8 really. So we got our numbers. Now we need to look at the masses. Container plus copper oxide, so before the reaction. Container and copper. So these two things are going to help us work out the mass of the copper and of the oxygen that is also present. So this take away this gives us copper oxide. So this take away this. So I'm going to go into my calculator. I'm going to do 26.97. What does that mean, man? Sorry, 1 second. I'll read that again. 26.97 minus 25.61. And we've got 1.36. Okay. So CuO, this mass is 1.36. And then if we want to work out the oxide, we just take away the copper and we'll get the oxygen. We'll get the oxygen mass. Okay. So if we take that, take away that, so we're going to go 26.97, take away 26.82, and we get 0.15. So the mass of oxygen, whatever that is 0.15, and the mass of copper is going to be this, take away this, which is 1.36, take away 0.15, and who got 1.21? So we got the masses, so that's good. So now we can go ahead and use that information. So CuO 1.21. I know I'm going fast, guys, but just it's in the recording, so just watch it back. I have to upload this one because a bunch of people couldn't make it, so I have to prioritize this one. Okay, so we're going to divide it by the MRs. Alright, how did you get 1.36? So for 1.36, I did this, take away this. Alex, man, I can't even blame you for that response. You have to upload it, but didn't say. Right, okay, so divide, let's go. I need some numbers, people. Yeah, I'm recording. Okay, I need some numbers. 1.21 divided by 63.5. Oh, snap. Why are they giving us these kind of numbers? I don't like these numbers. It's insane. This is when you start thinking things are wrong. 0.15 divided by 16. Yo, 0.009375. This is one of those things where you shouldn't look down when you're climbing these heights. 0.009375. 0.009375. Let's see. Hopefully this is not a flop. Can be a flop though. It's always possible. 0.1905 divided by 0.009375. Yo, I got 2. That's what I'm talking about. 2. That's what we need. I got 2.0 something. And this one is 1. CU201. Guys, did we see that? Did we witness it? CU2 plus CU2 and then a 1 after. Yes, exactly. Wait, wait a half an hour though. How many marks? I don't know. Something like this would be 4 marks, definitely 4 marks, because there's that calculation, and then you got to source the right value. So definitely 4 marks. Anyways, I got to move on, guys, because I didn't just want to do empirical formula. If you are still struggling with empirical formula, please tell me. I can always put a revision session right after our chemistry lesson on tomorrow. So whenever that is, or is it today? No, it's tomorrow. So I can always do it tomorrow. I can always do it whenever. Just tell me, communicate. We'll come back to empirical formula later. We have in spectacles, that's true. So I will come back to that. Next calculation. Okay. So here's a calculation. So let's say I have 17 grams of H2O. Find the number of atoms in H2O. When is Tanvi, I'm putting it in the chat now, yeah? 1 sec. It is Yasma. Thank you, Hassan. I would practice if it's the good. Let's go to formula. Whose idea was it to have chemistry done lit 52? I don't know. Is lit 52 Tuesday? Oh, okay. Unacceptable. Absolutely unacceptable. You do need that, Alex. Thanks, Tabby. Zion, are you working on this? Zion, I'm going to scroll all the way up now to your comment, because I saw that you put a comment, but I didn't read it, so let me go back up. Guess what? What? Don't chat. Don't chat. Stop with the conspiracy theories, man. Can the answer be in standard form? Please put it in standard form. If you don't, it'll be insane. No, that's my neighbor. They're building some, like, I don't know, some bouncy castle thing, and the kids are messing around. I think the dad's about to have a rage quit. Okay, yeah, another one. Okay, so H2O, what is it? H is 1, oxygen is 16, so mass MR is 18. Do you know what though? They did a great job for that biology paper, so I'll give them that. So what was it? H2O is 18, so mass divided by MR is moles. You know the exam QA channel? it has some good like streams before the exam, so check it out. If you're a person who just needs a bit of a reminder, an informal reminder, check it out. However, I'm not gonna tell you that it's the best if you want that grade 9. It's good for people who need a quick reminder on everything. Like they don't know what to revise, so they just need some informal revision. But yeah, so I'm gonna preface that by saying it's definitely for if you're stuck on like I don't know a grade 3 jail or 4 jail, then definitely lock in with that. That's quite good. They'll cover everything. What's the answer to this? Anyone have an answer? What is this? 0.94. 0.94. Okay, so to work out the number of atoms, you just do the moles times Avogadro's constant. Okay, now Avogadro's constant is going to be 0.94. That's the moles times 0.23. No, 0.02. 6.02. 6.02 times 10 to the 23. Yeah. Do we get the constant? Unfortunately, I don't think you do. I do not think you do. Can anyone confirm? I'm pretty sure you don't. I don't think I've ever seen it in some of the practice questions. You get it in NX. Okay, there you go. I don't think you do. It's not that hard to remember. 6.02 times 10 to the 23. So first you got to do this calculation. And what do you get? Do you get 5.63 times 10 to the 23? Is that what you guys got? I have written that so wrong. Is that what you get? 10. Come on, Krish, man. I'm moving at lightning speed. Hold on. I don't know if you put an answer. Now, you got to remember something, yeah? Guys, I need you to hyper focus on what I'm about to say. I need you to hyper focus on what I'm about to say. Are you listening? They wrote we wrote 5.63 times 10 to the 23 H2Os. So what does that mean? There's this many these. There's this many of these. Correct. There's this many of these molecules. Did the question ask for molecules or atoms? The question asked for molecules or atoms? Good. So this is what we've worked out is 5.63 times 10 to the 23 of these. Correct. We have to times it by 3. So 1 for oxygen, hydrogen, and hydrogen. So there's 3. So times your answer by 3. And whatever that is the answer. Okay. The question might say molecules. It might say atoms. It might even say, do you know what's so sneaky? How many oxygen atoms in H2O? Or sorry, how many hydrogen atoms in H2O? So what do I times this answer by? If it asks just for oxygen atoms, times it by 2. Okay, just oxygen. Sorry, just hydrogen. Just hydrogen, 2. Just oxygen, 1. I said both. I am saying too much. Okay? Okay, does that make sense? So whatever they've asked you to target, that's what you're going to do. I've seen questions where they've mixed it with full Erians, and it's some awkward like C60 something, and they wanted you to times it by 60 or something like that. So yeah, so be ready for that. So if it says molecules, you leave it. If it says molecules, this is your answer. If it says atoms, this is your answer. If they say hydrogens, then times it by 2, as in just this by 2. And if it's just oxygens, then it's that. All right, good. We're moving on. All right, easy one, yeah, easy one. We'll do one easy one and one monstrous. It won't be that bad. Right, okay, so have a periodic table with you people. Have a periodic table. Get the exam board one out so you know what you're looking at. What mass of sodium fluoride is formed when 2.3 grams of sodium reacts with 2.85? If this is something you struggle with anyways, just mention it in the chat. But try this out. I'll be back. I won't be long. Okay, I'm back. Wait, why are you using Avogadro's constant? It's not Avogadro's constant question. Who drew a table? Who drew a table? I always draw a table. Yeah, good. Just draw a table. It makes your life easy. I don't even know what the question is. I'm doing the method if you're for a person who feels like they stress with calculations. If you're a person who's good with calculations, do not draw a table. You're going to waste time. What's the moles of 20? What's the MR of 23? I mean Na 23, right? Fluorine 19. And then Na 23 is going to be what? 42. Sorry, Na 20. What am I saying? 30. It's 42, isn't it? Na 23. Yeah, it's 42. Ali, don't. Fluorine is 38 because there's 2. $200. Okay. Molar ratio. We need a molar ratio somewhere. We need a molar ratio. Molar ratio. 2, big 2. 1, 2. Okay. 2, 1, and 2. Okay. Any masses? What mass of sodium fluoride is formed when 2.3 of sodium? 2.3. Filling them in. 2.85. Okay. Oh my days. I didn't even need to draw a table. The atomic force. What do you mean, Nathan? I'm confused. Basically, if you look at this question, yeah, I just realized what's going on. Actually, no, you do need to draw a table. Okay, anyways, let's go. What mass of sodium fluoride is formed when 2.3? Yeah, because you do. By the way, guys, what I just said about not drawing tables, I did definitely need to draw one. Okay, that's because something here has been added in excess, and I don't know what it is. So, let's go with 2. Let's go with the sodium first. Okay, so let's do this one first. So mass. The formula is mass divided by MR. Is moles. So who did 2.3 divided by 23 and got 0.1? Anyone get 0.1? Okay, so that's going to be 0.05 and that's going to be 0.1. Anyways, so we're going to use these two pieces of information to work out this. So mass divided by MR. So X over MR is moles. Take that there. X is 0.1 times 42. Who got 4.2? Fluorine was 0.075. I don't know what planet you're on, my friend. But come back to Earth, please. Do you know how I got 0.05? I looked at the molar ratio. 2 and 1. Yeah? Did you get it? 2 and 1. I looked at the molar ratio. Oh, but what's it asking though? It's asking for... yeah, so basically, yeah, you're right. It is. It's added in excess. You're correct. So if you worked it out, if you actually went and did the calculation, it will be 2.85 divided by 38. What is it? 0.075. So it was added in excess. Can you see? Remember I said in the beginning we do need to draw the table because we need to figure out what's given in excess. But I didn't bother mentioning it because if you look at the question, they're just asking about sodium fluoride. So I can see here 4.2 is formed. Is that okay? How do you know that's in excess? Because I can see that the moles was 0.05 and the actual is this. So that means 0.025 was wasted. But how do you know that actually sodium isn't limiting? Okay, so if you did it the other way around... Oh, I just went with it. I just went with what it says in the question. What mass of sodium fluoride is formed when 2.3 sodium reacts with this? So I kind of went in the order. So if this reacts with this, but you can do either way if you want. You can do either way. Do both and see what happens. Just do both. Like for example, if this was 0.075, this will be 1. No, it won't. It will be 0.15. Right? That'd be 0.15. Now, if I did this calculation, if I did mass divided by 23, I won't get 0.15. So basically, what I would do in that situation is realize, oh, actually, it's the F2. So I think the moral of the story is just worth checking, because this question didn't say anything about limiting reactants. Should we do another one? How do we know that has 0.1 moles? Did I answer that question? Let me know. Looked at the periodic table and it told me that atomic fluorine, not mass. Oh. What was your answer? What did you get? Okay, I'll talk about the 0.1 in a second. How did you find the MR? If you look on the periodic table, sodium will have two numbers, 23 and 11. The MR is worked out using the 23. Okay. One second, Yasma. Is that understood firstly? Okay, awesome. So 0.1, the person who asked about 0.1. How did I get 0.1? So I used the formula mass divided by MR is moles. So in this question I had 2.3 and I had 23 and that was 0.1. So I filled it in the box. For MR, is there a number in front? Okay, you know how I wrote at the top molar ratio? You know how I wrote molar ratio? Because I wrote that, I'm ignoring all these numbers. I'm not even looking at them. So whatever I work out, so this was 0.1. So I considered the molar ratio. This is 2 and 2 to 1. So that's using my math skills, 0.05. Is that okay? Sorry, I'm sure there was other questions. I'm just going back up. So back to the question again. How do you know what's limiting? Work out both. Work out both. Work out which one the mass matches and the one the mass doesn't match. If it doesn't match, you know something's limiting. Okay, we're going to do another limiting question now. So, yeah. So let's look at this question here. This is a limiting reactant. So basically find out what's in excess, what's limiting. Excess just means lots has been added. Limiting means not enough has been added to reach the goal. So let's firstly get our key information. So the answer was 4.2. Yeah, guys, the correct answer for this question was 4.2. That's what's going to be, because I worked with the limiting. Work with the limiting. Yeah. Do you guys understand that? What I mean by that? If you work with the limiting, you're working with your weakest link, because that's it, right? You can't, just because I have 1,000 eggs doesn't mean I can make a big cake. I need other stuff. Right, what's everyone saying? You think watching there? Yeah, watch it, Zion, watch it. Good, very useful. Okay, so all right. Iron. What was iron? Iron was 63. Was it 63.5? Yeah, do it without it. Your choice. Do it without it. Was it 63.5? Can someone confirm? AL was... Oh, my bad. 56. Of course it is 56. What am I talking about? I knew that. I knew that already. I think. What is this? 27. Alright, we got all the key information. There's no other... Oh, there's oxygen as well. Alright, there's nothing else. Alright, I'm doing a table. You do what you gotta do, guys. Do what you feel, what you think feels right. And what you think feels right is draw a table. Molar ratio 1, 2, 2, 1. Mass mR moles. What mass of iron is formed when? So mass of iron, X. When iron 3 oxide, where's iron 3 oxide? Reacts with 2.16 of aluminium. So 2.16 of aluminum. Okay, right. Do I have any other information I can add in? Aluminum is 27. Fe is 56. Is formed when 8 grams of iron oxide. Iron 3 oxide. 8 Gs. Everyone add that one in. Thank you, Zeus. I think that's everything, right? What do they want us to work out? What mass of iron is formed? So X. So we need to work out the value of X. So we can use these two to help us, right? We can use these two to help us. So we're going to go with the formula mass over mR is moles. 2.16 divided by 27. Time to get a calculator out. 0.08. Who got 0.08? 0.08 moles. Okay, so now we just need to do is fill in the table, but you don't need to do this. I'm just doing this to show you. Can you see the molar ratio? Molar ratio. The molar ratio is 2 to 2, so that's going to be the same. And this is going to be 0.04, and this is going to be 0.04. You don't need to write those. The only one you needed to write was this. You okay with that? Awesome. Right, so I'm going to go back into my question. Why are you watting? Go on. What's up? Is it 2.24? I don't know. Let's find out. So we got the moles, we got the mass. So mass. No, we don't have mass. So X over 56 is 0.08. Well, what if you do that and the aluminium oxide is excess? Okay, no worries, no problemo. We're going to work out both. So 0.08, 56 times 0.08. 4.48. So we got 4.48. What is it? 4.48? Okay. So I'm going to write here in red 4.48. Is that okay? Now I'm going to check if these values match up. I'm going to check if these values match up. So we've got Fe2, so that's 56, so 112. And then oxygen, O3, 48. So what's that, 160? So 160. So we're going to see if these values match up. Then we'll know what's going on. So mass divided by mR, so 8 divided by 160 is 0.05. So this is a limiting. So we need to go back. Okay, so this is the weakest link. So now that we have worked out the weakest link, we have to go along with this one here. Oh no, hold on. We have enough. That's not the weakest link. That's an excess. No, hold on. 0.75. Yeah, this is an excess. We have this in excess. So this is an excess, so that's enough. So we've done it correct. So therefore, we do get this. So the answer is 4.48. Who got 4.48? I'm confused on the red bit. What's the red bit? There's a couple of red bits. 160, is that one? This one or this one? I can't right now, but I can set up another one.